Okay everyone, this is chapter 8 practice test question number 8. So we're taking a look at the base of a solid here. The curves here in blue are y equals x squared, and in red we have 8 minus x squared. It says the cross sections that are perpendicular to the x-axis are circles. So the first thing I'd like to do is take a look at, well, what exactly does the circle look like? So we know the cross section is perpendicular to the x-axis. So this is kind of where the cross section would go. We're going to draw a circle because that's what the cross sections look like. Okay, not a very good circle, but it'll do the job. And then that red segment that I just drew there would be situated like this. Okay, because it does say those are the diameters of the circle. Alright, so next thing we need to do is just figure out what is the area of that cross section. So if you remember, geometry, area is equal to pi radius squared. And then we need to figure out exactly how to get the radius from that red length. So I'm going to just put an L there for that length. And so if I take a look at that, I can see that the radius is half of that length. So our area formula can actually be turned into pi, half of the length, squared. Okay, well, how long is that length? Well, that length is the distance from the red curve to the blue curve, which is the difference in y coordinates. So the length is actually equal to y on top minus the y coordinate on bottom. These are general y coordinates, so we're going to be taking a look and seeing is there a function that goes along with it. And on top here we can see that it's on the red line, and that red line is 8 minus x squared. So the y coordinate, y equals 8 minus x squared minus the y coordinate at the bottom curve, which is this blue one right here. And that blue curve has the equation y equals x squared. So the y coordinate there is x squared. That tells us that the length is equal to 8 minus 2x squared. And if we're thinking ahead, we're going to be squaring half of the length, so that tells us we should figure out half the length. Half the length will be 4 minus x squared. And so now my area formula becomes pi 4 minus x squared squared. Okay, and now for the calculus part of this. If we want to find any volume, we just need to integrate our area formula. So we need to figure out from y min to y max, area formula in terms of x dx, and that's going to be equal to our volume. Alright, so what is our y minimum? Well, it's going to be this coordinate here, and our y maximum is going to be this coordinate here. I'm also going to take, let's figure out those y coordinates. At those y coordinates, the y coordinate for the, at those x coordinates, the y coordinate for the blue curve is the same as the y coordinate from the red curve. So the blue curve was x squared, and that's going to be equal to the red curve, which is 8 minus x squared. So let's see, that's quickly x squared equals 4. And that looks like we're going to get at positive and negative 2 for these coordinates, negative 2, positive 2. I don't recommend that you take a look at the graph and automatically assume that that's 2, even though it looks reasonably close to 2. it may not always be exactly equal to 2. So do some analysis, solve it, use your calculator to solve it, whatever you need to do. But don't assume that it's 2 just because it looks like it's 2. Okay, so our volume is equal to negative 2 to 2. Our area formula, pi 4 minus x squared squared dx. Next thing I'd like to do is, if I take a look at this region, I notice that the left side of the region and the right side of the region are actually symmetric. And that's nice because I can actually integrate from 0 to 2 instead of from negative 2 to 2. I mean, who wants to deal with the negative numbers, right? So we're going to change this, take advantage of symmetry, and say that this is actually also equal to 2 times the integral from 0 to 2 pi 4 minus x squared dx. And that's going to help me out when I evaluate the integral. So let's go ahead and integrate now. This is 2 pi integral from 0 to 2. We're going to expand that. That's 16 minus 8x squared plus x to the 4th power dx. I think my writing's getting a little bit wonky here. Sorry about that. So this is 2 pi 16x minus, see the antiderivative here is 8/3 x cubed. The antiderivative here is 1/5 x to the 5th power. We're going to go from 0 to 2. Take a minute, make sure you got the calculus part correct. And it looks good. So this is why it was nice for us to have that 0 instead of that negative 2 is because, well, as you can see, when I substitute a 0, I'm going to get a 0. We'll look at that in a minute. See, 2 cubed is 8. 8 times 8 is 64. So it's 64/3 plus 2 to the 5th power, that's 32? Yeah, 32. 32/5 minus 2 pi, and that is 0 minus 0 plus 0. If you didn't write that, my feelings aren't going to get hurt, but make sure that it actually is equal to 0. And I think you guys can probably get it from here. 2 pi, let's see, 32 minus, well, yeah, 320 over 15 plus, what is that, 96 over 15? And that's just arithmetic from here. This is an AP class, and on the AP test, you could actually leave this answer like this, and it would be worth full credit. If you have a calculator in front of you, as you will on my test, you might want to just go ahead and calculate that out. So that's question number 8. Yeah.